We just came from the longest problem on the test, which is going to be question or a format similar to question number 35. Let's go ahead in this video. Let me see. We'll try to do 36 through 38. All right, let's go ahead and move to question number 36. Actually, I might be able to get through 36 through 40. All right, for question 36 through 38, describe how many intercepts a parabola will have based on the value of the determinant. This is in your flip book under standard form, and we have talked about what the determinant tells you about the number of x-intercepts a parabola will have. So for question number 36, it's saying, what if the determinant is positive? And we know from your flip book and from experience that if determinant is positive, if determinant is positive, and I'll put a semicolon. Sorry, I'll put a colon here. If the determinant is positive, we have two x-intercepts. That would be kind of like pretty much a normal parabola that crosses the x-axis at two places. If the determinant happens to be equal to 0, so if the determinant is 0, that means we have one x-intercept. When the determinant is 0, it means the vertex is on the x-axis, and that means it will have one x-intercept. And then what happens if the determinant is less than 0? Class, that's when you get into situations where you've got a negative square root. You've got a square root that's a negative number. That ends up introducing the imaginary number I, which is the square root of -1. You can solve this kind of a question, but your numbers are going to be imaginary, and that means we could say if the determinant is negative, that means we have 0 x-intercepts. The parabola will never cross the x-axis if the determinant of b squared minus 4ac is a negative number. All right, let's get to some word problems. Number 39 and 40. Number 39. The flight of a football is modeled with the function h of t is equal to -16t squared plus 50t plus 2, where h of t is the height of the ball in feet, t is the time in seconds since the ball was kicked, 50 is the initial vertical velocity, and 2 is the initial height. What is the height of the ball at 1.3 seconds? Well, it's kind of a neat, class. They gave you the whole story, but basically here's the equation or the function. And all we have to do is plug in 1.3 as our t value. So we know that t is going to be equal to 1.3. And since a function is a predictor, it's a machine that predicts. In this case, it predicts the height of the ball in feet. All we have to do is write our equation and plug in time is equal to 1.3. So height equals h of 1.3 is equal to -16. Remember, your variable always gets plugged in parentheses. -16 times 1.3 squared plus 50, which is our initial velocity or vertical velocity, times 1.3 plus 2, which is our initial height. And when you plug that in your calculator, you should get 39.5 point, and I'm going to write this out to 2 decimal places, 0.96. So that means our answer is the height, and I'm going to write that in a different color. Sorry. The height is, actually let's do it this way, the height at 1.3 seconds, I can just put S, 1.3 seconds is 39.96 feet. Alright, so just plug in the t value and out comes the y value, which in this case is the height of the football. Alright, number 40, similar problem. Oh, sorry, not a similar problem. A firework is launched and the height is modeled with the equation y equals -16 times x plus 0.5 times x minus 4.5, where y is the height in feet and x is the time since being launched in seconds. If the firework does not explode, how long in seconds will it take to hit the ground, class? When we are hitting the ground, we are hitting the x-axis. That means we are looking for x-intercepts here. Now the thing you need to notice is, as I've told you before, let's identify what form this quadratic is in. Now the one in number 39 didn't matter because we're just taking a t value and plugging in. That could be vertex form, intercept form, standard form. You plug in t and out comes y, or the height of the football. In this case, we need to identify the form of the quadratic so we know how to find the x-intercepts. Well, the good part is this is intercept form. Intercept form. Intercept form gives us our x-intercepts. So you don't want to work too hard at this one. You've got intercept form, and that means our x-intercepts are going to be the x value that makes x plus 0.5 equal to 0, or x minus 4.5 equal to 0. So the x value that changes this to 0, subtract 0.5 from both sides and you will get x equals negative 0.5. Add 4.5 to both sides here and you will get x equals 4.5. Now, this is how long in seconds. We're going to have time on the x-axis, and negative time is never possible. So for the x equals -5, we can basically cross that out. Our value, our seconds that it takes for this firework to hit the ground is going to be 4.5 seconds. So our answer here is going to be, it takes 4.5 seconds. I'll just abbreviate that to hit the ground. So those two problems are pretty straightforward. Don't get confused again by all the words. You got to read the question, interpret what it's telling you to find. In this case, we knew it had to hit the ground, so we know it was going to be intercepts, and we have intercept form, so that makes intercepts very easy. All right, that's the end of 40. We'll start the next video at question number 41.